Okay, in this video we're going to go over a concept called significant digits, also referred to as significant figures or Sig Figs, or what you'll see me put on your test and quiz occasionally is SF. Significant figures is basically how long our answer is going to be based on the measurements that we're working with. Right, so let's talk about a little bit more about uncertainty and accuracy in measurement. Right, we already said that every measurement is going to have some amount of uncertainty in it. When we do our math, we have to account for this uncertainty. There are only specific digits that we can say that we are confident are correct. To do this, we use significant digits. A sig fig is all the digits in your measurement device plus one estimated digit. Right? So just as we were saying earlier with measurements, read them off the device, estimate the last one. If we give you a measurement, the last digit of that measurement is always estimated. How do we determine the number of significant digits in a measurement? Well, what we do is we look at zeros. First rule for determining the number of sig figs. Every non-zero number in that measurement is significant. It counts. Then for zeros, we have three different rules. Any zeros at the beginning of the number, so before the first non-zero, or what we call leading, those are not significant digits. The reason why is they are there just to hold place for the decimal. Right, so they never count for sig figs. So 0.00345 has three sig figs, the 3, the 4, and the 5. The 0.00 is just holding place for where that 3 should be. Zeros in the middle of a number, so between non-zero digits, always count. Those are what we call embedded. 1.00435. Those two zeros are between a 1 and a 4, so they both count. That gives us 6 sig figs. So we've talked about zeros at the beginning, we've talked about zeros in the middle. That only leaves zeros at the end. And for zeros at the end, it depends. If the number has a decimal point, all of the zeros at the end are significant. If the number does not have a decimal point, then those zeros are not significant. It means that that number was rounded. So as our three examples, 120 with no decimal point has 2 sig figs. What it means is we rounded that answer to the nearest 10. So it's somewhere between 120 and 125. The second example, 120.0, has 3 sig figs. The decimal point means we measured that 0 to be 0, so it counts. And our last one, 120.0, has 4. Because again, we measured the 120, that 0 before the decimal point was measured, and that 0 after the decimal point is our rounding 0, that's our estimated 0, so that also counts. One older thing that you may see with sig figs, by the way, is instead of putting a decimal point between numbers, you may see a line drawn above a certain 0. If you see a line above a 0, that means that's the last 0 in the measurement that is significant. Alright, so that's how we determine sig figs. Another rule for sig figs is any number that is known by exact definition has an infinite number of sig figs. So that means it doesn't affect sig figs in your calculations. Right? So for example, a dozen. A dozen is defined as 12 of something. So that means that that 12 is infinite number of sig figs. Or if it's an object and you count the numbers of that object, so if I count up the number of eggs I have in a carton and that's 6, it's exactly 6. There's no ambiguity. So infinite sig figs as far as your calculation is concerned. Now how do we do math? Well, we're going to break our math up into multiplication, division as one set, then addition and subtraction as the other. For multiplying and dividing, your answer can only be as long as the least number of sig figs you have. So if you're multiplying something that has 3 sig figs and something that has 5 sig figs, your answer can only have 3. As an example here, we have 5.33 times 9.1. We plug that in, our answer is 48.503. The thing is, the 503, not very significant because we can't go out to the thousands place in a calculation when our last measurement's only to the tenths. That doesn't make sense. What we're going to do is we're going to figure out how many sig figs. 5.33 has 3 sig figs. 9.1 has 2 sig figs. That means my answer can only have 2. So my 4 counts, my 8 counts, the 503 does not count. So what I have to do is 48.503, I round up the 8 because the number after it's a 5 and get 49. That's my answer for this question, 49. Right, and then 12.3 divided by 1.500, that is 8.2. Now notice, we have 3 sig figs in the numerator, 4 in the denominator. We have to have 3 sig figs in our answer, but right now it only has 2 listed. So what do? We add another 0 at the end. We call it 8.20 to give us that third sig fig. Right, so multiply and divide, do the operation, and then round to the number of sig figs of the measurement that has the least number of them. For addition and subtraction, it's actually a little bit easier to work with. What you do is you work with the decimal column. So the farthest column to the left that has a sig fig in it is where you're going to take your answer from. So for our first example, we have 180 plus 5.332. That gives us 185.332 as our answer. Now we'll look. The 5.332 goes out to the thousands column. The 180, though, only goes out to the tens column. So that means that my answer, the last sig fig in my answer, has to be in the tens column. So I get to keep the 1, I get to keep the 8, and then the 5332 is going to tell me what to do. That tells me to round up. So 185 becomes 190 without a decimal point. Right? No decimal point because we can't have that 0 count. And then for our other operation, 0.6875 minus 0.1. Our least significant decimal column in this calculation is the tenths place. So we're going to round to the nearest tenth. So 0.5875 rounds to 0.6. Those are calculations in sig figs. And then the only other situation we kind of have to worry about is what to do if we're doing multi-step calculations where we apply different rules. What you have to do here is you have to follow your sig fig rule as you go through. One thing I would like you to do, though, is do the exact calculation in your calculator and only round to sig figs at the end of the problem. So what we have to do is kind of keep in mind what operation and what rules for sig figs. So if we have an addition and a multiplication problem and we do the multiplication last, I would add my 2 numbers up and then multiply, figure out what decimal column I'd be using for my addition. That would tell me the number of sig figs I would use with the other measurement for my multiplication. It may sound somewhat complicated. It's really not. We'll do a lot of practice with this in class, so if it doesn't make sense right now, that's okay. It will after we've done a handful of these. But that's sig figs. Basically, the idea is that based on your measurement, your answer can only have a certain number of digits in it. When you give me a numerical answer, I expect it to always be to the correct number of sig figs. I will take off deductions if they are not. I'll see you guys in class.